All right, so for the first one, most of you probably simplify that in your head, but what you were really doing as you were simplifying is you were factoring the 12 into two factors of 4 times 3. And then you were factoring the 9 as 3 times 3. And so ultimately, what happens to those 3's? They cancel out. One of the 3's on the top cancels with one of the 3's on the bottom, and you're left with 4/3. So most of you got 4/3 with that, with kind of doing this part in your head. But the reason we're able to reduce this into 4/3 is because they both have a factor of 3 out in them that we can cancel out. Now for the second one, what do we have to do for the second one? We have to add first. Okay? Because when you have a fraction written top bottom like this is really an imaginary set of parentheses. So we end up with 12 over 9, which is the same thing we just had, which would be 4/3. What you cannot do is you cannot cancel out those 4's, because if you cancel out the 4's, you get 8/5. Is 8/5 equal to 4/3? No. So essentially, the only thing you can do, or only thing you can cancel, is when your numbers are separated by what operation? Multiplication. Okay? You cannot cancel if they're separated by addition. So what we're going to do then is apply that to problems like this. So if I had x minus 2 times x plus 1 and x plus 2 times x plus 1, again, there's multiplication between parentheses like that. In this case, we could cancel out the x plus 1's, and we would just get x minus 2 over x plus 2. Again, that's because it's separated by addition. Sorry, because it's separated by multiplication. For the second one over there, where it's separated by addition, can we cancel anything out? No. So we'd have to just combine like terms here. X plus x is 2x. Negative 2 plus 1 is negative 1. And on the bottom, x plus x is 2x plus 3. And there's nothing else we can do to that. We cannot cancel anything. We can't cancel the 2x's out because, again, separated by addition subtraction. Yes. Yes. So, no. The only thing we have to, the biggest thing you have to take away from this is that you can only cancel factors which are separated by multiplication. Okay, as we go through here, you may have seen like graphs with holes in them when you took algebra 2 or pre-calc. Remember, those holes mean there's no value there. Okay, so like if you go back and think about domain for this parabola on the right would be negative infinity to infinity, all real numbers. Our domain for the graph on the left still goes from negative infinity to infinity, but there's one x value that doesn't work. The x value here that doesn't work is when x equals negative 3 because there's a hole there. So that's what we call our exclusion. Every number works except negative 3. So we're going to talk about how we can get these exclusions coming up also. All right, so if we look at checkpoint 1, so you can go ahead and take a moment and write those 3 problems down. The directions say find all the numbers that must be excluded from the domain of each rational expression. So when we have a fraction, what can your number never equal on the bottom of a fraction? 0, because then it's undefined. So what we're going to do to find our exclusions here is figure out what x value would make our denominator 0. Because when our denominator is 0, it's undefined. So essentially all you're doing here is looking at your denominator, setting the denominator factor equal to 0, and solving that. So when x equals negative 5 plus 5 is 0, and 0 can't be in the denominator because it's undefined. So our exclusion, because the answer says what numbers must be excluded, we would have to write x cannot equal -5. That's our exclusion. So we're just saying what x cannot equal. That's what we mean by an exclusion. Because if it did equal -5, -5 plus 5 is 0, and our denominator is 0. Now for b, it's not quite as easy because what do we have to do first? We got to do difference of squares. Very good. We got to factor it. So that happens to be a difference of squares. So I would take the square root of x squared, which is x and x, the square root of 36, which is 6 and 6, and we have opposite signs. So now I'm going to have two exclusions because I have two factors. So I would set x plus 6 equal to 0, and I would set x minus 6 equal to 0. So this first one would be -6. So I would say x cannot equal -6 because -6 plus 6 is 0, and then 0 times anything is 0. Same thing with this one here. I'd have to add 6, and so x cannot equal +6 either. So I wrote this as x cannot equal -6 or 6. Again, 6 minus 6 is 0, and then 0 times anything is 0. All right, try letter C on your own. You're going to have to factor and then set each of them equal to 0. All right, so what would we factor, or how would we factor the bottom? Yeah, we're doing the same factoring. So what multiplies -14 adds to -5? And so when we set each of those factors equal to 0, we would say x cannot equal +7 because we have to add 7, and then we have to subtract 2, -2. So our answer here would be x cannot equal 7 or -2. All right, then the examples that we're going to be looking at for today, where we're actually simplifying these fractions. So it's kind of like the first problem we did when we had 12 over 9 and we reduced the fraction. So now we just have x's in our fraction, but we're just trying to reduce the fractions that we see here. They have x's in them. So to do that, to simplify a rational expression, so these are called rational expressions when it's a fraction, and in those fractions you have x's in it. That's a rational expression. First step is to factor the numerator and the denominator completely. Okay, so first step is to factor. Once we factor, then we can divide any numerator or denominators that have the common factors. So we can cancel out any common factors, kind of like we did on that first problem where the 3's canceled. Or, if we kind of go back here, like we were able to cancel the 3's, or like we were able to cancel out the x plus 1's. As long as it's factored, separate by multiplication, we can do that. So as we look at our first example, x cubed plus 3x squared divided by x plus 3, again, step 1 tells us we need to factor the numerator and the denominator, both. So which one can we factor for letter A? And how can we factor it? Right, we can pull out a GCF of x squared in our numerator. So I'm going to divide each of my terms by x squared. I'm going to make sure that GCF stays in front. And I would be left with x, because x cubed divided by x squared is just x. And then 3x squared divided by x squared is plus 3. On the bottom, I have x plus 3. Can I factor x plus 3? No. So I'm going to leave that in parentheses. I'm just going to put it in parentheses to kind of note that I tried to factor and I can't. And now we have multiplication right here. So we can cancel any like factors. So what factors are going to cancel out? X plus 3's will cancel. X plus 3 on the top, x plus 3 on the bottom. So we are left with x squared as our simplified answer. And then we do need to write our exclusion like we just did. So again, any denominator factor, the only factor in our denominator is x plus 3. I set that equal to 0. So I'd have to say x cannot equal negative 3. Again, it can't equal negative 3 because negative 3 plus 3 is 0. And then 0 would be in our denominator, which is undefined. So that's our full answer. We need the reduced fraction, which is x squared, plus the exclusion. Yes, sir.
Why would it not equal negative 3 x plus 3 on the bottom?
Because negative 3 plus 3 equals 0, and 0 can't be in the denominator or else undefined. For part B, we got to factor the numerator and denominator now. So how can we factor the numerator? Right, it's a difference of squares, so that would be x plus 1, x minus 1. And our bottom would be factored with Sam. So it multiplies to 1 and adds to 2. 1 and 1. So both positive 1s. Again, we have multiplication between those parentheses. So now we can cancel any like factors out. So what's going to cancel out? One of the x plus 1s on the bottom will cancel with the 1 on the top. So we're left with an x minus 1 on the top and an x plus 1 on the bottom. And x cannot equal negative 1. Very good. Again, it's the same thing twice, so we don't have to write it twice. Yes. All right. You are working on your homework, which is page 8, numbers 7 to 13 all.